put on the thing, like what roles I wanted, and then I was like, probably not gonna get it. So I don't know, I put this on there. She's like, write down what roles you want, so that I can have you read for them.
Okay, the first thing we're gonna do, let's do it. Okay? Alright, first thing is double angle formula. We're gonna do 3 different types of formulas today, and I'm only gonna give you an example of one of each of them. So we're gonna have 3 examples today. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 different formulas, 3 for each topic, okay? And these are in the blue boxes in your book. Don't be writing them down while I'm showing you how to do this. Okay, you really need to understand what it is that we're doing. You can go back through as you're doing your homework and write down all of them on your cheat sheets. You need to have these. Now, the other thing I want to tell you is I've been working in Chapter 8, and in 8-4, I'm using the double angle formula. So don't think that you can forget this stuff. And how I'm using basically is I need to recognize that I need to use it, or recognize it when I see it. So you need to make sure you have your cheat sheet out, your reference sheet that has all of the formulas on it, so that when you say, oh, I think that is a double angle formula, let me look at that, maybe I can use that. So make sure you just don't forget these. I didn't say you had to have them memorized, but you got to be fluent with them. You got to at least be able to identify what it is you're talking about. So the first formula I'm going to use is the sine of 2x equals 2 sine of x cosine of x, which is great because sine of 2x, that just means 2 times whatever the sine value is and the cosine value is, which is awesome. So we're going to do a problem. I'm going to do I'll do an even one. I'm going to totally give you the even or the odd problems today. Tangent of x is -4/3. This is number 4 in your book, okay? And we're in quadrant 2, and I'll tell you why that's important in a second. Okay, so for today's homework, we kind of were forced into coming up with values that we didn't understand much. We had to use right triangles to figure some things out. The inverses, you have to make sure you're fluent with inverses and stuff like that. Today, the beginning part, tangent of x equals -4/3. It wants to know what the sine of 2x is, and the other angles, the other double angle formulas as well. I'm just going to do the first part of this. How do I transmit this into this value? So the sine of 2x is this formula, double angle formula. When you double the angle, what can you get? It matches this value when you do that. Okay? So that doesn't mean anything at the moment. Tangent of x equals -4/3. What is tangent? It's the same as opposite over adjacent. And in your video last week, or over the weekend, I said make a right triangle for the value that you've been given. Okay? Now, here's the problem with this. This is in the second quadrant. So it does help to draw it in the right position. So I'm just going to write a nice little right triangle over here like this in the second quadrant, where the opposite leg is 4. 1, 2, 3, there's 4. And the adjacent leg, so the opposite leg is 4, this is 4, and the adjacent leg is 3. 1, 2, 3. Okay, so what is this coordinate? That's not trick, what is it? -3/4. Right, the x value is negative. So if that helps, you could write it like that. So make sure you understand it. Now, this is 3, this is 4. What's the hypotenuse? Pythagorean triple. Very simple. 5. Alright, having said that, all I have to do now is, what is the double angle formula? Well, that's twice the sine of x and the cosine of x. You now know what the sine of theta is. The sine is opposite over hypotenuse. The opposite is 4 over the hypotenuse. So that's going to be 2 times 4/5. And the cosine of x, cosine is the adjacent leg, -3, over the hypotenuse, -3/5. And you just do the calculation. 2 times 4 is 8 times negative 3 is negative 24 over 25. Negative 24 25ths. So that's using the double angle formula. Are we applying it yet? Are we using it for anything specific? No. So what is it that you have to do today? You just have to take the information given, figure out what all the pieces of the triangle is, okay? What they all are. Plug it into the double angle formula that it's asking for. In this case, at the beginning, it's asking you to take this information, do the sine of 2x, then you're going to do the cosine of 2x, then you're going to do the tangent of 2x, and it gives you the formulas to plug those values into it. Okay, step 1, take this information, draw your triangle in whatever quadrant it's telling you so that you know where your negatives are at, figure out the missing piece, and then fill out the rest of the formula. Okay? Got it? Yes or no? Lost? Who's lost? Raise your hand. Okay, a few of you. I'll do one more. How about I do a totally different one? Or do you want me to just do the cosine of 2x from here?
Different one.
Both? Okay, cosine of 2x. In your book, it shows you actually 3 different ways to do the cosine of 2x. I'm going to just go ahead and do the top one here. Cosine squared of x minus sine squared of x. So the cosine of 2x equals those two things squared. Well, I've already drawn my triangle to get these pieces. So what is the cosine? Negative 3/5.
Are you still using the same information?
What?
You're still using the same information?
Yes, for this one problem. You have to do this for each problem. You have to do the sine 2x, the cosine 2x, and the tangent 2x. And you're just filling in the pieces. Okay? So cosine is negative 3/5. You gotta square it. The sine we said was 4/5. And you gotta square that. So that's 9/25 minus 16/25. Negative 7/25. Just finding values now. We're doing the beginning part of this. We aren't even doing an application yet. Can you get the information and plug it in? That's what we're doing. And that's all we're doing today with each thing I'm going to show you. I'll do another problem just like this so you can see how we get started here. I'll do, how about number 8? Secant of x equals 2. X is in quadrant 4. We're in quadrant 4. Okay? So, what is this number? What did I say? 8? Alright, so we'll do 2 sine of x. We need to do this. 2 sine of 2x equals 2 sine of x cosine of x. Okay, so we're in quadrant 4. Let's draw a triangle. The secant of x is what? What do we know that to be? What is another way to write secant of x? 1 over cosine of x. Okay? So, which is just the x value. Alright, so 1 over cosine of x, we are in the 4th quadrant, and it equals 2 over 1. Cosine is what? SOHCAHTOA, cosine is?
Opposite of hypotenuse. Wait.
Adjacent over hypotenuse. So secant is hypotenuse over adjacent, right? Hypotenuse over adjacent, 2 over 1. Hypotenuse, alright, so we're over here, hypotenuse is 2. The adjacent leg, this is going to be this one, is 1. So I need to get this leg here. So I need to use the Pythagorean theorem to get that other piece. Right? Alright, so 1 squared, we'll call this b, plus b squared equals 4. B squared equals 3, 4 minus 1. B equals the square root of 3. Now that I have all the pieces, I can just fill that stuff in. Okay, so you need to understand SOHCAHTOA. That helps you with your triangles. Where to set them up. You just have to put them in the right spot. Now, let me ask you something before you start doing the values. Is there anything that should be positive or negative?
Negative 3 should
Hypotenuse will always be positive.
the square root of 3.
Yeah, this is negative there because it's in the fourth quadrant. Now, 2 times sine is opposite over hypotenuse. The negative radical 3 over 2. Cosine, adjacent leg over hypotenuse, 1/2. And then you just do the calculation. Is that better? I didn't say it was easy. You do have to think about it. But you use SOHCAHTOA to put you in the right position to get all the pieces. Yes? Obviously, this is the first thing you have to do. And this, you're going to do this a lot in different sections as we progress. Being able to find out the other pieces that you need. Unit circle is used in a whole lot of things. We need to make sure we can do them. Just because we don't have the the secant of 30 degrees doesn't mean we can't figure it out. Okay, and when you do that, you get negative radical 3 over 2. That's the answer. Okay. All right. And then again, you do cosine of 2x, and then you do tangent of 2x. But you have to do this to get these answers, to be able to do those formulas. All right, lowering powers. Oh, let's see here. What do I want to do here? Lower powers. Let's do cosine to the 4th x. Well, you're given 3 formulas for one for sine squared of x, one for cosine squared of x, and another for tangent squared of x. Okay? We have cosine up here, but it's cosine to the 4th x. How can I make something to the 4th look like something squared? Just algebra. Can I just say that this is cosine squared of x times cosine squared of x? That's really how simple it is when you're doing this today. Okay, now, so here you had something you had to do first, and then you plug the values in. This is the first thing you got to do. You got to make it into all squares to match your formulas. Now you have to apply what the formulas say. Cosine squared of x is this. 1 plus the cosine of 2x over 2. So I have 2 of those. And then I have to multiply those together. Okay? This is number 16. So I would never ask you to do something like this. This is cosine to the 6x. This is cosine to the 4th x. Cosine to the 6x would just have another one of these here. This is a binomial. This is 1/2 plus cosine 2x over 2. 1/2 plus cosine 2x over 2. You have to do FOIL or distribution to work it out. And then you combine like terms. And it's kind of ugly. Okay? But as you can see, that my final answer, one of the answers down here, it was pretty long. Where I'm not looking for a specific value like this. This ended up giving me a value, a number value. This is just going to be simplified. There's no equal sign up here, okay? So you need to get in your head, if there's an equal sign, maybe I can actually come up with a value. This is just an expression that you're manipulating it using your lowering powers formula. Yes?
Does that say 1 plus cosine?
Yes, 1 plus cosine 2x over 2, 1 plus cosine 2x over 2. Okay? So if I distribute that, that's going to be 1/2 times 1/2 is 1/4. And I'm going to just gonna rewrite this. So it looks like binomials. And 1/2 times that would be 1/4 cosine of 2x. This is gonna be 1/4 cosine of 2x. And this is gonna be 1/4 cosine squared of 2x. Anything common in all those?
1/4.
1/4. 1 plus cosine of 2x plus cosine of 2x plus cosine squared of 2x. Anything else?
2x.
Huh?
2x.
The cosine 2x?
Yeah.
And we have 2 of those? What's this look like? We're done at this point, but this is a trinomial here. And that would be the answer. So here you're solving. There's equal signs. You're using double angle formula, actually come up with a value. Here we're manipulating, changing it because we don't like things that are bigger than 2's so far in trigonometry. Okay? So we're learning how to lower those powers, and then we can do something with them. Because don't you know cosine of 2x? It's a double angle formula. So if you had to, and you needed some values and you had some information, you could work it out and deal with it. Alright, that is lowering powers. Very simple. Change it so you have squared terms and then plug in the formulas and simplify. Just like this. Got it? Or you can plug in stuff. You guys are good at substitution. And the last thing, half angle formulas. Let's do it over here. We had double angle formula, now we got half angle formula. Don't worry, this is just half of the assignment. Half angle formula. Alright, so I'll just write one up here. Sine of u over 2 equals plus or minus the square root of 1 minus cosine of u over 2. Let me grab one that we can work on. Let's do number 20, sine of 75 degrees. This is number 20. I'm doing the even ones because I'm going to give you just the odd ones so you have those answers and solutions you can work through. Okay. Could I come up with a number that's divisible by 2 that equals 75? What would that be? What? 150. 150. So let's just say u is 150 degrees. And we apply, because you can't tell me what the sine of 75 degrees is. You could use your sine addition formula. Remember we did that. That was part of your assignment. 40 and 35, 45 and 30. You did know those. But let's do it another way. Half angle formula. 150 divided by 2. So we have plus or minus. Notice we have equal signs here. Plus or minus 1 minus the cosine of u. What did we say u was? 150 degrees. You got your unit circle information stuck in your brain. Cosine of 150. What's the cosine? What's the x value at 150 degrees? Negative radical 3 over 2. Alright, so now we have plus or minus the square root of 1 minus negative radical 3 over 2 all over 2. Okay? And then you just have to do that calculation. That's plus 2 over 2. I'm just going to roughly push this out. 2 plus radical 3 over 2 all over 2. So I've got a common denominator here. Put those two together. fraction inside of a fraction. Top times the reciprocal of this. Plus or minus square root of, we flip this over, it's going to be 2 plus radical 3 over 4. Plus or minus square root of 2 plus radical 3 over 2. Pretty ugly. Again, that's a value. You could actually put that in your calculator. Show that. And it should match if you put sine of 75 degrees in the calculator. That decimal should be the same as what you get here. Okay? So there's a sine of u over 2, there's a cosine of u over 2, and a tangent of u over 2 formulas that you can use depending on what your problem is. So sine of 75, you just have to multiply whatever those degrees are by 2, and that's what your u is. Okay? So if I said sine of 15 degrees, you would say sine of 30 over 2. And you plug it in here, and you know what the cosine of 30 degrees is. All right. That wasn't too bad. That's the beginning of your assignment. Okay? All right, so your assignment for that is page 514. I want you to do 3 to 27 odds.